So in this problem, what we have is a problem in which you're taking bids from 6 bus companies for operation on 8 routes, and the cost is given there. So say, for example, company 1 bids for route 2 at a cost of 8,200, route 3 at a cost of 7,800, route 4 at a cost of 5,400, route 6 at a cost of 3,900. Company 6 bids for route 1 at the cost of 7,000, route 2 for 5,800, route 3 7,500, route 4 4,500, route 5 5,600, route 7 6,000, and route 8 4,200. You'll notice here, for example, company 4 does not bid for routes 1 and 2, and for route 6 it bids for all of the routes. So some routes it is bidding for, some routes it is not bidding for. So what we do, and then we are also given another information, is that in this problem particularly, the company 1 decides to place bids on the routes 7 and 8. So you see in the original table, company 1 had not placed a bid for 7 and 8. So here an additional bid is given for routes 7 and 8 at a cost of 5,200 and 3,300. So now what I do is that I put this into this table. This table is similarly taken from this, except for these cells which are marked in orange. There you will see that I have put a very large number for places where a company has not bid for a route. So if you look at this one, this particular cell, company 1 did not bid for route 1. So this was blank. So what I did was I took a value of 10,000 and I put it there. The reason why I chose 10,000 was two things. One is that we are trying to minimize the total cost of covering all routes, right? So we have to choose each company in such a way that all the routes are covered, and we are also the condition, the assignment must be such that each route is covered only once. That's a very, very, very important condition. Each company can get at most 2 routes. So that's the second condition, right? So with these, and of course we want to minimize. So with these conditions, let's look at this problem. So if I were to, put this as in this way, that say, for example, C1 R1 is the cost of company 1 to operate on route 1, route R1. So suppose that is the situation. And similarly, we have PC1 R2, PC1 R3, PC1 R4. So for example, PC1 R2 is equal to 8,000. C6 R3 is equal to 7,500. So in this way, we have these different values that is given to us. Now we need to allocate. So for that purpose, what we'll use is binary variables. So binary variables we'll use in this way. Say X C1 R1 is equal to 1 if company C1 operates route R1. Similarly, C1 R2 will be the equal to 1 if this is XC1 R1 is equal to 1 if company C1 operates route R1, and is equal to 0 if company C1 does not operate route R1. So we can have similarly, many such binary variables. So the last binary variable will be XC6 and R8. Right. So this will be the last binary variable. So here my problem that becomes is like this. So it is minimization of x C1 R1 into P C1 R1, right? And then you'll have all these different numbers in between, and the last one will be x C6 R8 into PC 6 R8. Right? So this will be my objective function. So what I'm trying to do is that in this way I'll be able to know what is my total cost incurred in allocation of these routes. Now, because I'll have to have a route operated by only one company, so what it means is that x C1 R1 plus x C2 R2 plus x C3 R3, like that, plus x C6 R1, sorry, it's only R1. R1, we are looking at route 1. This will have to be strictly equal to 1, because the route 1 has to be operated only once, right, by any one company. Similarly, for route 2, it will be x C1 R2 plus x C2 R2 plus x C3 R2 plus x C6 R2 will have to be equal to 1. Like that, we'll do it for all the 8 routes, and last one will be x C1 R8 plus x C2 R8 plus x C3 R8 plus x C6 R8 will have to be equal to 1. So that ensures that each route is being operated by only one company. Now we have to also ensure there's one more condition which says that if a company can be assigned at most 2 routes. This is another condition that we have, right? Which means that for each row now, so x C1 R1 plus x C1 R2 plus x C1 R3 plus x C1 R4 plus, like that, will go up to R8 x C1 R8 will have to be less than equal to 2. Right? For company 1, we cannot have more than two routes being operated by that company. Similarly, we'll have for route. So similarly for company 2, we'll have XC2 and then we can have for all these 6 companies, and finally the last company will be XC6R1, XC6R2, XC6R3, XC6R4, and plus and XC6R8. That will have to be less than 2. So if you put it in all these conditions into your solver, you will get your answer.